Hello guys, welcome to Everything Metallurgy and welcome to day 78 of 100 days 100 concepts. Today in this video, let's discuss about extinction conditions in XRD. So what is extinction condition? So basically, you don't get to see all planes diffractions, right? So we know what is Bragg's law. Only planes which are actually obeying Bragg's law will give you a diffraction spot in a pattern, right? Similarly, extinction condition will actually explain you that all planes will not be able to diffract it until unless some conditions are followed for different crystal structures. That means extinction is actually nothing but absence of peaks, okay, the intensity peaks. So usually we know what information that we get intensity versus 2 theta, and you see different peaks coming in, right? This is what you get to see in XRD, and according to theta you get to calculate my interplanar spacing from 2d sin theta equal to n lambda, and finally from d you get a by root of h square plus k square plus l square, and hence this plane. That's fine, but now how to actually know what crystal structure will give you what peaks, or what planes will give you the peaks? So for that condition you have something called as structure factor. Okay, so FHKL will be equal to sigma F into EXP of 2 pi I into HU plus KV plus LW, where HKL is nothing but the plane itself and UVW is the position of an atom. Okay, so let's consider a BCC. BCC structure has atoms at corners. Okay, let's take the reference as origin, and also it has at the body center, which is half, correct? Now putting in it FHKL for, of course, BCC will be equal to sigma, or if I write for two atomic positions, it will be F into EXP of 2 pi I into, initially we have 0, 0, 0, so this is 0, plus F into EXP of 2 pi I into, here we have half into h plus k plus l, correct? So if you carefully see, e power 0 is 1, so this is f plus f into exp of, so half gets cancelled, pi I into h plus k plus l. Okay, so this f whatever we have is actually helping for intensity, because I is directly proportional to f square. Okay, f is nothing but the structure factor and I is the intensity of the peak, right? What if by changing HKL you get different f values and different intensity values, of course. Now let's take 0, 0, 1. Okay, and what is this e power pi I? So usually we write e power pi I as cos pi plus I sin pi. This is what we write, correct? So now just take 0, 0, 1. So if you take 0, 0, 1, so f 0, 0, 1 will be equal to f plus f into e power of, so this is pi I into 1, h plus k plus l is 1 now, so this is exp of pi I, okay, which is what I wrote here, e power pi I. So if you carefully see, this is equal to minus 1 plus 0, sin pi is 0, so e pi I, e power pi I equal to minus 1. So from here if you write f plus f into minus 1 minus f, which is equal to 0, therefore 0, 0, 1 will not give you a peak in XRD because the structure factor itself is 0. Again we are considering what, BCC. Similarly, let's take 0, 0, 2. Now if we consider 0, 0, 2, again for 0, 0, 0 we get f itself plus f into exp of pi I into 0 plus 0 plus 2 is 2. Now we have 2 pi, right? So this is 2, this is 2, this is 2. Now what happens? Now cos 2 pi is plus 1, sin 2 pi is 0. So this is f plus f, which is 2f. Therefore, here you can see that in BCC itself, 0, 0, 1 is not giving you any peak, but 0, 0, 2 is giving you some peaks. That means that there should be some condition from this guy over here. So here for BCC, when h plus k plus l is even, you get this term as minus 1. Then only you get to see f as 0. When if it is even, that means when h plus k plus l is even, then no worries, you get to see n intensity peaks. That means for BCC, diffraction is actually present when H plus K plus L equal to even. Similarly, now what I want you guys to do is take FCC, and FCC also you get equation, you get that equations, and there you get when H plus K plus L are unmixed only, you get to see diffraction patterns. Okay, what is unmixed? Unmixed is nothing but all odd or all even. Okay, so here 0 is also considered as an even, and simple cubic every plane will give you. Okay, and what is extinction condition? Now extinction is when it will be absent, which is just vice versa of what we have discussed till now. So if H plus K plus L equal to odd, then the peak is absent in BCC. Similarly, when HKL are mixed, that means if you have even and odd mixed, then it won't give a peak. That means it's an extinction condition for FCC. Similarly, in simple cubic, all are actually obeying and all are giving you diffraction. So none of the planes are actually giving you the extinction condition. Therefore, this is how we got it. I hope this table many people saw previously, but they don't know from where people have derived this. So the fact behind it is the structure factor. Okay, so structure factor will be different for different crystal structures. I hope you like this video. If you like it, please hit the like button and also share with all the GATE Metallurgy aspirants. So please do visit everythingmetallurgy.com and enroll for GATE 2022. We have already opened GATE 2022 enrollments. So please do visit everythingmetallurgy.com. Thank you guys. We'll meet you tomorrow with one more interesting video.